Well, hello, friends out in EDD land. This is Dan Garrison. I'm here to ask you one question. You got a screw loose in your classroom, or maybe 1,000 or more? If you're a PLTW engineering teacher, you may have encountered this problem, and we're here to help you and your students get some time and your sanity back. And I'm here to help introduce the Loose Screws team, who've been working on solving that problem. I'm Dan Garrison. I'm an engineering instructor and robotics coach at Woodrow Wilson High School, Academy of Engineering in Dallas, Texas, where I've been for 6 years, and I just completed my 10th year of teaching after 20 years in private industry. And I'm grateful to be here with my two talented teammates, and I'll turn it over to them.
My name is Tim Milkey. I'm the STEM Academy Director at Shoreland Lutheran High School in Summers, Wisconsin. Privileged to teach PLTW, POE, AE, and hopefully EDD, not the too long future. Also serve as one of the robotics coaches. I've been serving as a teacher there for 5 years and overall for 20.
Hi, good afternoon. My name is Susan Ewens. I'm the engineering technology instructor, new shop instructor at Greater Lowell Technical High School. I am going on to my 5th year, so I've only taught about 5 years, and this will be my 2nd year as a shop instructor. Because of COVID-19, I only had a partial year last year.
We determined, as we talked through potential problems, that one of the problems we saw as being significant within our own classrooms was the issue of sorting VEX parts and pieces, particularly screws. When we followed up with some surveys, we found that about 77% of you said that that was an issue with your own classrooms, that you spent up to 50 hours per year sorting screws manually into their potential organizational bins. What we equated that to was a loss of teacher prep time to engage students and prepare lessons for the classroom. A loss of student time as students were spending time in cleanup rather than being involved in the APB projects that PLTW makes part of their curriculum. And finally, a loss of resources, because at the end of the day, walking out of your classroom, oftentimes you ended up seeing screws laying on the floor. And that, for me, was particularly frustrating and a pet peeve of mine. So that brought us to screw sorting dystopia. Help us out. Well, what did we find? Commercially, we found that there are machines available, but they're expensive. They're not necessarily specific to the type of job that we're looking to do. And they're custom. So you're going to pay a lot of money for those, not something school districts can afford. There are also some do-it-yourself options, whether those be motorized or manual, both of which are not bad ideas, but don't necessarily solve the problem that we're trying to do, because they're loud, they're difficult to build, or again, they get away from the automated component. And so our job was to find a solution that would automate this process to bring us to screw sorting utopia. Build it once and whenever and forever. To do that, we had to look at some critical design pieces. We identified 2 of those. A hopper to take as an intake for all the different screws that we were going to pour in, and then also the sorter rail and how that would be oriented to the prototype. So we looked at 2 different hopper options, one that had a wheel inside of it, an intake roller that would funnel the screws through it, and the other one that used an agitator motor. Both are viable options. We went with the radial hopper design with the intake roller. The second element, critical design element, was to look at the rail sorter. That was our solution to get the screws into the appropriate storage bins and containers. And that, we believed, would bring us screw sorting utopia. Susan is going to share some more on the CAD designs behind those prototypes.
Thank you, Tim. So I took over to the CAD section of our project just because I had Inventor on my computer and I had that readily available. What I was responsible for is creating a virtual prototype structure and integrate our custom components with VEX components to see the visibility of the actual build. And I also created the 3D CAD components based on Dan's sketches for the rail component and Tim's sketches for the hopper design. And I try to include symmetry and simplicity in my design because it'll be easier for students to build this if this project ultimately is given to other project leader teachers. Here I'm just showing some isometrics and some general drafting design work that was based on dance sketches.
Well, and that brought us to this lovely moment where we're unveiling the slot machine, the name of our future product that we hope will be in everyone's classrooms and not in your hands. You'll load the screws and you'll get more time to maybe teach a language or pick up some time savings jackpot or call your patent attorney, maybe call our patent attorney. But I'm going to bring it on to Tim's going to tell us how we got to this point.
Thanks, Dan. To get to this point, we obviously put together a decision matrix like many of you. We prioritized our design criteria in order. So at the top, you'll see in the screw length differential was the top priority, being able to manage the different screw lengths and get them into the appropriate bins. To do that, we felt that we needed to have a hopper that could take those screws through accurately and efficiently without jamming. To get them to the appropriate slot on the slide rail. Storage bins were also considered. We figured that most teachers utilize some sort of big box store storage bin, and so that's what we proposed as part of the design element. I believe that Dan, you're taking us through some of those initial designs.
Yes. So in my situation, I was fortunate to be able to put my hands on some physical materials, including VEX parts, most importantly, the screws, and some supporting materials that allowed me to do some testing for the slotted rail sorter, which I prototyped using both cardstock and 3D printed PLA based on Susan's CAD models. We do have a collection of videos for those of you who are curious to see how those performed. I'm going to show some data shortly, but we ran 2 sets of tests, both on cardstock and the printed PLA. And then Susan actually had a virtual model that she tested. She can tell us about.
Okay, so I just wanted to talk about the video right here. Unfortunately, I don't think you're going to be able to see it.
We will return to your scheduled programming shortly.
But basically, it just steps you through the model that you can see the things that we had to, as we have a physical model, to illustrate how to make the components work together and see some of the advantages and disadvantages of our design, our initial design. So next. Okay, so I'm not going to get into the whole details of these formulas. They're based on someone who was looking at evaluating threshes in a 3D. So we're just talking about axial stresses, tension compression, and stresses that also consider shear, like von Mises stresses.
And these STEM principles 2, 3, and 4 that you see here all really relate to each other, as we were obviously focusing on the sorting of the screws with our rail sorter. And so the screws interacting with the materials was going to be an important choice, and evaluating that friction, calculating that friction between steel and the cardstock and steel and PLA. And we had to invoke some inclined plane principles. And if we had more technology, we could have done some work around calculating friction with kinematics. And I think Tim's going to tell us about the other principle we were working with.
Yeah, principle number 5 just simply looked at future functionality, recognizing that PLTW is going to be pushing forward the V5 platform from Vex Robotics. How can we use the V5 brain, the motors, the various sensors to increase functionality, accuracy, and efficiency with the prototype that we had developed? Dan, if you want to jump to Gantt chart next. Like many of you, trying to compress this massive project into the 10 days that we had, like was accurately said, drinking from a fire hose. This is our overview of what that looked like. We did have some mottos that went along with that. If you're going to fail, fail fast, frequently, early, often, but for the win. Because, Brian, give me an amen to this, it's all about the process.
Okay, so unfortunately, I couldn't actually have a model to actually test. If I had a 3D printer, I would have actually printed the hopper and the intake roller and see how, in terms of Vex motor speeds, what optimal speed will allow to do dispensing. And also, if there's any features that need to be changed to have control of the dispensing, so only one screw comes at a time. Next slide.
Yeah, and I was in a different situation with physical components on hand, so I conducted 2 sets of tests, both with the slotted rail sorter, one with the cardstock design, and one with the 3D printed PLA. We have a collection of videos, short slow motion videos. If you're interested in watching those, we will happily make them available to you. But we got some really important results from that, which we're going to talk about just briefly. The cardstock testing, as you can see here, there was some significant passing. We just ran a pass-fail test, whether the screw was overcoming static friction at various angles of inclination, rolling down the slotted rail sorter. And so that was helpful to see, but there was an entire row of failure, except for one pass in the 3 different size screws we were testing, in actually reaching the correct slot, which led us to consider that the PLA would be a lot more accurate and precise. And so we'll look at those results, but we see all sorts of failure here, including overcoming the friction at almost any given angle. We weren't able to, the apparatus didn't let us test this particular part of the configuration. But these results actually did reveal some very helpful data that helped us fail forward. And that took us to a couple of recommendations we'll share before we wrap up. And Susan's going to tell us about some of her hopper stress testing that she did in Inventor.
Yep, so unfortunately I couldn't build it, but I could do some stress testing and do some preliminary design work and evaluating virtually. So I looked at the 3 primary stresses, the axial stress with shear, and then the principal axial stresses, tension compression. I based it on maximum torque of a Vex motor, as well as 101-inch screws being a little more than a half a pound. And I applied as pressure and moments, and did a stress analysis on ABS materials. Long story short, factor safety of almost 100. So our design is very robust. Future considerations might be maybe creating a thinner shell, maybe even looking at lighter materials or a simpler design that doesn't need to have the level of thickness that this does.
Yeah, and speaking of some of the future refinements and additional iterations, we did rank a few of our top choices on next steps on the journey towards screw sorting utopia. The first one would be to eliminate the rail sorter trench that you can see in this picture of the slotted 3D printed rail. This particular trench at the top did not function when the screws got inside of these actual slots. And if we got rid of this trench and possibly combine both parts A and B that we had separated earlier into a single unit, we could find the optimal gap. And once we design a joiner from the hopper to the rail sorter, that would allow for some significant improvements. And then there's, as Tim has mentioned, all sorts of opportunity to apply tech apps for further automation and reliability. So we think this is a very viable product design that is headed in the right direction.
To put together a project of this magnitude in the amount of time that we were given, you couldn't do it without the help and support of some really awesome people. And so we want to thank Tony and Brian, especially for guiding us through this EDD Core Training and helping us bring a project idea like this close to fruition. We also have to give a shout out to some of Dan's helpers like Abraham, who was our 3D printer tech and was quickly running pieces over to Dan so that he could perform some of the tests that we're able to see to determine reliability and functionality.
So that brings us to a close for now, and I want to take a moment and just thank my teammates for being incredibly hard workers and
I
sharing
had
their
excellent
talent.
teammates as well.
Fantastic.
This was a great experience. We've learned a lot from everyone
Yeah,
in
this
this
is awesome.
course, and the leadership that Tony and Brian brought. And we thought we'd have a little fun here at the end, impersonating some of the Ocean's 11 folks. We named this the slot machine. So it's time for Q&A, and we thank you for your time and attention.